This chapter is about the mathematics of money. Please forgive my voice, I've got a little bit of a cold. So we're going to start off with just a basic review of percentages. Percentages, I believe, were developed by people who hate fractions. If I asked you to compare 47/53 versus 29/34 and said, quick, which one's bigger? Most people couldn't guess correctly, and you might think, okay, well, they're both more than half. So about the easiest way to do this is to turn each of these into a decimal. So I'm going to do 47 divided by 53, and I get 0.887. That's rounded to 3 decimal places. And 29 divided by 34, and I end up with 0.853 rounded. And now if I said which one's bigger, we could definitely say that 47 over 53 is bigger. And a lot of times we'll, instead of saying 47 out of 53, we'll say this is 88.7%, or this is 85.3%. So when we're dealing with fractions, if we want to compare them, sometimes it's hard to see in their fractional form. I love this little comic over here too, because this reminds me of my kids. Wait a minute, why'd PJ get 4 sandwiches and I just got 2? Funny. All right, so to be successful in this chapter, one thing you have to be able to do quickly and effectively is to turn percentages into decimals and decimals into percents. This should be second nature. So just as a reminder, if I have a percent, that literally means per cent or per 100. And so if I want to take something from a percent, I can just divide the number in front by 100. Another way to think about this is that you could take wherever your decimal place is and you can scooch it 2 decimal places to the left, whatever makes more sense. But you need to be able to get from 85% to 0.85, from 37.65% to 0.3765. You need to know that 2% is 0.02 and not 0.2. And if you get confused, you can always just take the number in front of the percent sign and divide by 100. 4.75% would be 0.0475. And 125%, that would give me 1.25. 400%, that's just 4. So when we're dealing with numbers, if they have the percent sign, we need to scooch the decimal 2 to the left, or you can divide by 100. If you want to take it from a number into a percentage, you would move the decimal place back the other direction, or you could think that you want to multiply the number by 100, because that sort of undoes the divide by 100. So 0.92 would give me 92%. 0.036 is 3.6%. And 1.02 is 102%. The thing you want to really watch out for is getting an answer to a problem like 0.61 and knowing that you need a decimal, knowing you need a percentage and saying that's 0.61%. Those two things are not equal. So be careful when you get an answer that you know what that number represents. If I get 0.61, it means 61%. 0.61% is very small. That's less than 1%. All right, so working with percentages, you need to be able to find basic percentages, like your math test score was 46 out of 67. So 46 divided by 67. And I end up with 0.6866, etc. If I was going to write this as a percentage, I might say this is approximately 69% rounded. How many decimal places do you need? Well, that just depends on the problem and what makes sense in the nature of the problem or what the instructions tell you to do. What about a tip? You generally tip 15% of your restaurant bill. Today your bill is $16.82. What tip is exactly 15%? So to take a percentage of something, you would multiply. So 1682 times 15%. That gives me 16.82 times 0.15. I end up with $2.52. It's actually 0.523, but again, since this is money, we would want to use 2 decimal places, 2.52. Now, what would you actually leave? And this is an opinion question. Me personally, I probably wouldn't add $2.52. I'd probably put $3 on there. Maybe you'd put $2.50 instead of $2.52. Someone in one class often says, well, I would put $5 because I never tip less than $5 no matter what the bill is. I know other people who try to add up the pennies so that it always gives you an even zero at the end. So maybe you tip $3.18 here so that you could get zeros for your checkbook. What percent is that? So to take a percent, remember a percent is the part out of the whole. In this case, the part is the $3. That's what the tip was. And I want to know what percent is that of my bill. So the bill would go on the bottom, $16.82. So I'm going to take the part, $3, and divide by $16.82. In my calculator, I end up with 0.17835, etc. And so what percent is that? It's approximately 18%. Okay, just a real quick hint here. If you are in real life, you should be able to calculate a percent relatively quickly. 10% is a 1 decimal place shift. So if I had a bill of $16.87, 10% would be $1.68,169. Or if I was really dealing with this, I'd probably say, it's about $1.70. This is about $17. So 10% is about $1.70. So if you wanted to leave a 20% tip, which is pretty typical, all you have to do is double that 10%. So in your brain, you shift the decimal place once, and then you double that answer. $3.40 is an approximate 20% tip. If you wanted to calculate 15, well, 10% is easy. 5% would be half of that. Now, me personally, I go to divide 17 and okay, that's like 85 cents or something like that. I would make this as easy as possible on myself. I think, what about $1.80? That's easy to divide by 2. Half of that is 90. I can put my $1.80 and my 90 cents together to get $2.70. That is approximately 15%. Now, remember, we calculated that on the previous page and got $2.52. So we're only off by 18 cents here, which is not that big of an increase. Okay, so again, just a real life skill everyone should have. How about this problem? Yesterday, 22% of my 250 students were absent. How many were present yesterday? So you might say, well, I could take 22% of 250. 22% of 250.22 times 250 gives me 55. And you'd have to think 22% were absent, so that means that 55 were absent. How many were present? Well, if there were 250 total and 55 were absent, that leaves me with 195 were present. Now, you could also think about it this way. Another way to approach this similar problem would be to say, okay, I know that there's 100% and that 22% were absent. That means that 78% were present. And 78% of my 250 students gives me 195. Either way, you end up with the same answer. But it's important every time you're dealing with a percentage that you consider that every percent usually has a complement. If there is a 22% of the kids are absent, then 78% were not absent. They were present. Or if there's a 10% chance of rain, there's a 90% chance of no rain. Every piece of information should have a complement. And sometimes it's easier to work with the complement than the percentage itself. How about this one? You forgot your coat on vacation and you have to buy a new one. You pick out one price, $50.64, and the bill comes to $54.94. What is the tax rate? Now, you could guess and check. You could say, well, Indiana is 7%, $50.64 times 7%. Is that the right answer? Is it too high? Is it too low? So you might be able to guess. Another thing you might start off thinking is, well, what if we figured out what the taxes actually were? So we paid $54.94, and the coat cost $50.64, which means that we paid $4.30 in tax. Now we could treat this just like the percent problem with the tip. If I want to know what $4.30 is as a percentage, I would divide that by my price. Now which price? I've got two. Always pick the original price. $4.30 is what percent of our original purchase price, which is $50.64. So 4.3 divided by 50.64, and I end up with 0.084913, etc. Okay, so it's approximately 8.5% is our tax rate. There's another way you could do this same problem, another way to think about it. You could take your new price divided by your original price, and that would tell you that your new price is what percentage of your old price. So I could take my $54.94 and I could divide by 50.64. When I do this, I end up with 1.0849, etc. Or in other words, I ended up with 108.5%. So my new price is 108.5% of my old price. Or in other words, there's the 100% and an 8.5%. I expected to pay the 100%. That's the price of the coat. The 8.5% was extra. I paid 8.5% more than the price of the coat. That's my tax rate. So that's just another way you could think about this same problem. All right, what if we had to pick the best option? So you want to buy an iPad mini. And these numbers were accurate several years ago, but they're probably a little out of date now. Option 1, you look at Best Buy. You have one on sale for $249.99. Sales tax is 7%. So we could take our $249.99 and multiply by 7%. Remember, 7% is 0.07. All right, in my calculator, $249.99 times 0.07. That comes up to approximately, and I'm going to round to 2 decimal places here because it is money, $17.50 in tax. So that's an additional $17.50 that we have to pay. So I'm going to tack that price on. And what we end up paying for the iPad would be $267.49 if you shop at Best Buy. Okay. Well, what about Amazon? On Amazon, you get free shipping because you're an Amazon Prime member. It costs $289.99, which is more than the Best Buy, even after the taxes. You still have to pay taxes, but you have a gift card from your grandma for $25. And you think that seems like a pretty good deal here. So let's take our $289.99. And Amazon is going to charge you that same 7% Indiana sales tax here. $289.99 times 0.07. And that comes up to $20.30 in taxes. Okay, so we have our iPad, and we have to tack on that $20.30 in taxes, but we can take off that $25 gift card from Grandma. And this comes up to $285.29. All right, so even with the gift card from Grandma, this is not a better deal than buying at Best Buy. In fact, it's kind of depressing. Grandma basically just paid for your sales tax, which is probably not what she really wanted to do with that money. All right. What about you have a buddy in Oregon who says he'll buy it and ship it to you? Now, why Oregon? Because in Oregon, there is no sales tax. He goes to Bob's Electronics Outlet, and he sees it priced at $267.99, and he also has a coupon for 5% off of one item. So we can take our $267.99. We could take off that 5%. So $267.99 times 0.05. Okay. his coupon will save you $13.40. Now, that's a coupon. So we're going to take that $267 and we're going to subtract off that savings. So $267.99, we would end up paying $254.59. Now, on the surface, this seems like a really good deal. This is better than Best Buy. This is better than Amazon. But unfortunately, he lives in Oregon and you do not. So I looked up how much it would cost to ship an iPad from Oregon to Indianapolis, and that's $10.99 plus $10 in packaging, because you really don't want him to ship the iPad in an envelope. So we're going to go ahead and tack those shipping costs on. Maybe you can convince him to send it for free. Say, hey, buddy, it's my birthday. Come on. All right, so I'm going to I'm going to add on that price there. That makes us end up paying $275.58. Which is better than Amazon, but not quite better than Best Buy. So you really ought to take option 1 here and just go buy it locally. Right now, this doesn't have to be the same every single time, but different scenarios you need to think about would be what a discount would do, what sales tax does, and adding and subtracting. This is kind of an inefficient way to do this problem, though. Notice that every time I calculated sales tax, I had to take the sales tax and figure out what it was, and then add it back on, or the discount and then subtract it back off. There is a way to do this all at the same time. And if you turn to the next page, there's a nice little formula box here. Okay, so when you're dealing with percent increases and decreases, a really quick way to deal with these problems is to start with a starting quantity, which we could call Q. And we have some sort of percent of change, like 7% sales tax or like a 5% discount. If you want to increase your starting quantity to get a new quantity, instead of multiplying and then adding, you can do both steps at the same time in a parenthesis. So you can take your original value and do 1 plus x over 100, or in other words, 1 plus the percentage. To do a decrease, like a discount 5%, you could take your original quantity times 1 minus x over 100, or 1 minus the percentage. This is a quicker way to do this. It'll give you that new quantity much quicker than the adding and multiplying separately. Okay, so you have a 20% off coupon for Kohl's. Sales tax is 7%. How much will you pay for a sweater that is priced at $35? $35 is our original price. That's what we're going to start off, our starting quantity. Also, I see I have a 20% off coupon. Now, that's a decrease. So I can say, instead of multiplying by 20% and then subtracting, I can do this all at once. 1 minus 20 over 100, or in other words, 1 minus 0.20. I also know that sales tax is 7%. That is an increase. So instead of multiplying by 7% and then tacking it back on, I'm going to do that in one step. 1 plus 0.07. If you want to simplify a little bit to make this easier on your calculator, 1 minus 0.2 is 0.8. And 1 plus 0.07 is 1.07. You could also punch this original step into your calculator using parentheses. You could type in 35 times parentheses 1 minus 20 close parentheses times parentheses 1 plus 0.07 close parentheses. All right, so 35 times 0.8 times 1.07, and we get a new price of our sweater, a final price of $29.96. Okay. Your boss is giving you a 3% raise. You currently make $10.50 per hour. What will you make per hour after the raise? So we're going to start with our $10.50. And we could multiply by 3 and then tack it on. But since this is an increase, I should be able to do this all in one step. 1 plus 3%. If you want to make it a little easier on your calculator, you can turn that into 10.5 times 1.03. But you could also type this in just as it stands, 10.50 times parentheses, 1 plus 0.03, close parentheses. All right, in my calculator, I end up with a final answer of $10.82, rounded to the nearest cent there. So that's not real impressive, but it is something. You see an ad that says that a new diet program will drop your weight by 5% in the first month or your money back. You weigh 150 pounds. What will you weigh at the end of the month if it works? So 150 pounds is our starting amount. And it says it's going to drop our weight by 5%. That is a decrease. So I should be able to do 1 minus 0.05. If you want to type that in your calculator, you could put that in as parentheses 1 minus 0.05, or you could take 95% of 150. So 150 times 0.95. And we end up with 142.5. And this is not dollars this time, this is pounds. So these problems 8A, 8B, and 8C, there are several ways you could do this, but using this idea of the parenthesis and the increase with a plus and the decrease with a minus is just quicker. It's a quicker way to get to that answer you're looking for. So what about D? A clearance sign says everything is 25% off. You have a coupon for an additional 20% off of clearance items. What percentage are you actually saving? Now, I'm going to tell you right now that the wrong answer is 45%. That's what a lot of people would say. Okay, that is the wrong answer. It's not 45%. You're going to take 25% off, and then you get an additional 25% off of the clearance item. So your 20% isn't coming off of the original price. It's coming off of that reduced price. The other issue you might see in this problem is that there is no original quantity. So here's what we're going to do instead. We're going to say that we start with a 100% of the price. That's our starting amount. And I'm going to deal with this everything 25% off like a discount. 1 minus 0.25. An additional 25 or 20% off we could enter as 1 minus 0.2. Now 100% as a decimal is just 1. 1 minus 0.25 is 0.75, and 1 minus 0.2 is 0.8. If I put this into my calculator, 1 times 0.75 times 0.8, I get 0.6. And since I started with a percentage, I should end with a percentage. 0.6 is 60%. So here's where we can see our discount. We started with 100% and we ended with 60%. So after the two discounts, our price is now 60% what it was. So if you start with 100 and you ended with 60, there is a difference of 40%. So 40% is your actual savings. Notice that it's not 45%. I just can't add the two percentages together. All right, next question. The principal states that the number of Saturday school sessions assigned to students has decreased by 6% over each year for the last 3 years. What is the overall decrease for the last 3 years? Now, the wrong answer, the one you're really tempted to say, is if it's decreased 6% per year for the last 3 years, then it's decreased 18%. But that's wrong. Because each year, if you're decreasing by 6%, you're not taking 6% of the original value. You're taking 6% of the new value, which is smaller. So we're going to have to do this same thing again. Since he didn't tell us how many Saturday schools there were, we're going to start with 100%. And I'm going to decrease by 6%, 1 minus 0.06 for the last 3 years. 1 minus 0.06 and 1 minus 0.06. Now again, 100% is just 1, and 0.06 minus 1 is going to give me 0.94. And since there are 3 of those, I'm going to go ahead and just put a 3 exponent on that. If you want, you can write 0.94 times 0.94 times 0.94. All right, so 0.94 raised to the third power. I end up with approximately, now this is rounding, 0.830. So I'm just going to say 0.83 or 83%. So if you started with 100% and you ended with 83%, what you actually have here is an overall 17% decrease. Okay. You read that your favorite stock was up 1.4% on Monday, down 3.4% on Tuesday, etc. You have all these increases and decreases. If you invested money on Monday, did you make money or lose money this week? And what percentage? Okay, so let's start. Again, we don't know how much money we invested, but we can start with 100%. It's up 1.4%. That's an increase of 0.014. Down 3.4% would be 1 minus 0.034. Up 5.2% on Wednesday, that's 1 plus 0.052. Up 1.3% on Thursday, that's 1 plus 0.013. And down 2.3%, that's 1 minus 0.023. Now you could go through and simplify these if you wanted to, and you could also just put them into your calculator as they stand in parentheses. That's probably the fastest way to do this due to the tiny nature of these numbers. So I end up with 0.966 for this one, and 1.052, and 1.013, and 0.977. All right, so I'm going to tack this whole thing in my calculator. 1.014 times 0.966 times 1.052 times 1.013 times 0.977. And I end up with 1.0198, etc., or approximately 102%. So if I started with 100% and I ended up with 102%, I definitely made money. I increased my value, and I made 2% extra. The difference between the two. Now another formula we have up here in the box is a percent of increase and decrease. And I want to point out in this formula, I have on here to find a percent change, to find the actual percentage. You take the original value minus the new value and divide by the original value. But what we're really interested in here on the numerator is the absolute value. What I'm really looking for is how much did it change divided by the original. I'm not really concerned if that number is a negative or a positive. I just want to know what the difference is. Okay? All right, so you see this sticker on a product, and it says, what is the percent of markdown? So the original price is $29.99, and our new price is $23. So I'm going to find the difference, $29.99 minus 23. Okay. The difference is $6.99. And now we can take that difference, $6.99, and divide by the original value, which our original in this case is $29.99. Okay, so 6.99 divided by $29.99, and I end up with approximately 0.23 or 23%. Since the price went down, that is a 23% decrease. Okay? You buy an American Girl doll for $120 and then you turn around and sell it for $180. What is the percent profit that you made? So again, I want to find the difference between these two numbers. And I'm not really concerned about the order in which I'm subtracting them. I'm mostly concerned with what the change is, the absolute value of that change. And I get that I made $60. So we're going to take that difference, $60, and we're going to divide that by the original value. The original value was 120. Okay, so that gives me 0.5. Or in other words, I made 50% profit, or we had a 50% increase. Now there's another way to think about these two problems too, if you want to, that doesn't really use the formula, just a different way of thinking about the same thing. And that would be that you could take the new price divided by the original price, and that'll tell you what percentage you are actually paying. So in this case, the price was $23, and our original price was $29.99. If I do this in my calculator, I get 0.77. Or in other words, I paid 77% of the original price. So you can think about if 77% is what I paid, then I got a discount of 23%. Same thing over here with the American Girl doll. If I take my new price and divide by the original price, my new price was $180. My old price was $120. I end up with 1.5. And that's 150%. That means the person who bought this bought it for 150% what I bought it for. So if they bought it for 150%, that means that they paid a 50% increase. So basically you're looking for the difference from 100% if you want to do it that way. That's just another way to think about it. As far as these problems go, there are lots of correct ways to work them out. It's important that you understand your logic and that you get to the correct answer. But if your method doesn't look the same as mine, that's fine. Logical reasoning has definite perks here, definite pluses here.